Today's topic is the benefits of multithreading. Using multithreading, your program runs faster and your development is simpler. However, creating a new thread is not free. JVM needs to allocate memories. It also needs to handle multithreading. So multithreading only makes sense when each thread will do a large amount of work. It doesn't make sense when you have a lot of threads, each one just do a small amount of work. Let's illustrate this point with an experiment. Here we have a 4000 multiply 100 amount of work to do. That's 40,000 total calculation units. In each calculation unit, we increase the number, then add it to a set. This set is thread safe, so we call add. And we have three different strategies. We can have one single thread do all those 40,000 units of calculation. We can distribute the total amount of work to 400 threads, each one do 100 units of calculation. When we use multithreading, we can use the intrinsic lock to guarantee thread safety, or we can dedicate the thread safety to atomic long. Here we have total run. As any experiments, we do the experiment many times and we take the average time. That's why we need this total run. The test bench is simple. The initial init just zero out all the test bench variables. And the test, we pass in the type. If we want to run a single thread, we just use this method. This method iterates through the total of calculation need to do and do it. If we want to run multi-thread with atomic, we pass in true. If atomic is true, we use atomic runnable to do the work. Here in the run function, each thread increase the same number through the atomic long. Since atomic long is thread safe, we don't need any synchronization. And this statement is thread safe. We need a countdown latch. At the end of each run method, the countdown latch is countdown, and we only start to calculate the total amount of time when the last thread count down the latch. Another running strategy is passing force. At that time, we want to use intrinsic lock. Here is the implementation. In the run method, we use the intrinsic lock of bank object to make sure we have thread safety. So this statement is thread safe. However, at any time, only one thread can execute this statement. So the performance is not better than the single-threaded counterparts. Here is problematic. We didn't take the advantage of multithreading. However, we take the overhead of multithreading. So we expect this running strategy is even slower than a single-threaded in a single-thread counterparts. Last, let's mention why we need this discard first view. When the compiler is execute, when we execute this program, somehow the compiler is trying to optimize your code. So during the first few runs, the time is the time is much longer. So we just don't want to include them. We just want to include those stable time. Of course, we can make this a large number, so we don't have to throw away the first 20. It will be average out. Let's run the program. We have total 4 CPU and we have 4,000 threads, so that's a lot. Single thread takes 6 milliseconds, multi-thread make it worse. Atomic long didn't save us too. We run this again and should got the similar result, around 6 milliseconds. And multi-threading make it worse because it only takes overhead, didn't take the benefit of multi-threading. Atomic long didn't do any better. We can change the strategy. Use less threads, each one do more work. Single-threaded have the same performance because same amount of work. And multi-threading performance is improved. Atomic long improve even more. We run this again. And we got a similar result. Let's take it further. We have 4 threads. Each one do more. Same amount of work. So single-threaded, keep the same. And multi-threading, the atomic long, already beat the single-threaded performance. Again, beat the single-threaded performance. So here, this experiment illustrates the benefit of multi-threading and the disadvantage and the overhead of multi-threading. It only makes sense if each one do heavy lifting and we have small amount of threads. Also, the synchronization didn't lock down too much. That's demonstration of this topic.